So x bar, which is the sample mean, is the sum of x1, the first entry, plus the second entry, plus dot, 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 plus the last entry, n being the sample size. Remember, lowercase n is the sample size. Uppercase N is the population size. All divided by their number. Since they're n, n. So in this spot, if you printed out this document, you can put it in. So x bar is the sum, but we will not write it like this. Of course, we will write from I equals n, from I equals 1 through n, from xi over n. This is the correct notation for x bar. Of course, the notation is very similar for the population mean. So it's the sum from, of course, xi, you don't need parentheses, from I equals 1 till uppercase n, divided by uppercase n. And that was it for the first page. Now, I would like us to illustrate how to compute the mean, and then we're going to move on to the median. So this was the first measure of tendency, the mean. And then we move on to the next one, number 2. But let's quickly put in this data set. So we have a student variable, which is, of course, qualitative. And we have a quantitative variable in the second column. We just want to put these in StatCrunch. I am going to share my screen right now. I see a chat. My apologies. Sorry I'm late. That's okay. That's no problem. Tyler, I cannot see you. Are you there, Tyler? Okay, excellent. So I'm sharing the screen. Great job. So I have started StatCrunch somewhere right here, but I did not put anything in there. So let's call our variable grades. So if you'd like to call this grades or anything else, whatever you want, and let's enter it. I can dictate it to you. When I enter it, 84, let me know if you fall behind, 77, 90, 71, 62, 68, 72, 84, 94, and 88. If you'd like to also enter it in the graphing calculator, so I'll show you in a minute after I stop sharing. Okay, so I'm going to save the file because we will come back to it and I don't want to lose it. So I'm going to save the file. I'm going to give it a name of grades.
Excuse me?
Yes, please.
So I was able to get the passcode and everything to get into StarCrunch, but it still says I need to pay for like a subscription or whatever, and I don't know really what to do.
Are you using Chrome?
Yes.
Can you clear your cache and your cookies and everything else? Like from the browser, I mean, and the cookies and the cache. A student had this difficulty over the weekend from my colleagues' classes, the lady who went in maternity leave, and she couldn't see the course at all in My Labs Plus, at all. So can we address that after class? Can you stay a few minutes, or you have another class to run to?
No, this is my only class today, so I should be able to stay active.
Okay, very good. Sorry about that.
It's all right.
Okay, save results and graphs. I'm going to click this, and I'm going to save. Okay, thank you very much. It's in my data folder. Let's go to Stat, and let's create the summary. And we want the summary to be on columns. We are looking at a column. I'm going to select at the top. If you fall behind, stop me, please. I'm going to select at the top grades, And for now, I only want to see the mean. So what the calculator or StatCrunch will do, will add them up and divide by their number. How many there are there? 10. So I'm going to click on compute, and I will get the mean of 79.
What did we press to get there again? Sorry.
Okay, no problem. So we go to Stat, Summary Stats, and go to Columns.
Oh, okay, thank you.
And then select the column that you want to create the stats for, the summary stats for, and then select just the mean for now. Okay, so I'm going to stop sharing for a second because I want to show with the graphing calculator. So you go to Stats and Edit. So you want to edit a list. Because I have so much information here and I don't want to delete them yet, I will go to list L7 myself, and I will punch in the information, and I have 84 and 77 and 90 and 71 and 62 and 68 and 72 and oh, I did something. Sean, where are you? 84, 77, 90. If you don't keep an eye on me, I'm deducting a point from each test. I'm kidding. I'm kidding. I'm kidding. I'm kidding. I'm kidding. I am kidding. I'm trying to put a smile on everyone's face today. Okay, so I got the data in my list L7, and I go to Stat, and this time I want to go to Calculations. And I will choose the very first one variable stats. We will use all, or not all, but many of the other options. But right now we only want one variable stats. But remember, my list is in L7. So with the second key and 7, and 4. Sorry, where's my 7? I don't have 7 here. I have to select it from here. Okay, I don't have it. Doesn't allow me to select my 7. Here it is. I have to select it from somewhere else. Okay, so calculate, and I see the very first entry as the result, X bar 79. So I will say that for our example 1, let me get my keyboard out of the way. For example 1, we got the sample mean to be 79. Okay, our next measure of central tendency is called the median. So number 2, median. Normally denoted by uppercase M. So this was X bar, lowercase x, not this, but this, okay? And the uppercase M, which will require us, number 1, first of all, what is the median? The median is the middle of the data set. Let's say I have this data set. I'm going to arrange them in ascending order, but I'm going to do that with a graphing calculator. So I go to Stats. I want to sort in ascending order. I will select number 2. Stop me if you fall behind or if you need help with anything. And I want list L7. I want it sorted from the smallest to the largest. So because I'm in L7, I go to second in lists, and I look for my L7. It better be there. It is. Press enter. I always like to close parentheses and press enter, and it says it's done. So when I go to my L7, it better be sorted. I'm going to copy the sorted list from the previous example as 62, 68, 71, 72, 77, 84, 84, 88, 90, and 94. 2, 4, 6, 8, 10. Correct. because Sean is watching, so I have to make sure I don't make mistakes. Okay, so because they are 10, which is an even number of entries, I come to the middle of the data. So 2, 2, 2, 2. So this is the middle of the data. In order to determine the median, I have to create the average. So the median will be 77 plus 84 divided by 2. So the central of the data, if we have an even number of entries, is right here in the middle. It's not this, it's not this. It's right in the middle. It's an entry that I really do not have. So when you add 77 to 84, and you divide at the end by 2, we will get 80.5, which is not in this case an entry in the data set. We don't have that element. So let's go back for a second. I'm going to share again. And with the same data set, let's create, go back to stats, go back to summary, go back to columns. And this time I'm still selecting grades, but this time I want the mean. I also want the number of entries, and I want the median. And I'm going to click on compute. So we have 10 entries, we have the mean of 79, and we have the median of 80.5. So you will see how these two work together, or which one is preferred when. So let's talk about the median for a moment. We said that the mean is used for approximately, really? 3 pages? Okay. For approximately or symmetric, approximately symmetric or symmetric distributions. When do we use the median? The median is normally used for skewed data. Since, so for skewed data, since it is resistant. I like to call them resilient.
I still see your screen. I don't see the data.
Oh, thank you. Okay, you want to take over from Sean? I think he's not paying attention today.
I think you do your thing.
I'm kidding. I'm kidding. Sorry about that. So we said that the mean, let me go back because now I realize that nobody could see what I was saying. So we know that the mean is normally used for, we will determine it for everything, but the mean is really significant, or is a better measure of the central tendency for symmetric or approximately symmetric distributions. So now the question is, when do I use the median? I use the median for skewed data to say, where is the center of the data? Where is it? When the data set is skewed, then I use median. Why is this resistant? Why is the median better for skewed data? Simply because the median will not be pulled to the left or to the right as fast as the mean will. So let me explain why. So let's say we have two situations. Here is one situation. Obviously skewed to the left. And of course I'm going to graph something skewed to the right. Okay, perfect. So the mean in the skewed left, the mean of the distribution will still stay with the bulk of the data, will still be a better measure of the central tendency. But the mean, I should have just put the X bar, but the mean will be pulled to the left. What does this mean? It means that the lower entries I have here, those entries will make the mean move that way, but not the median. Because adding one more or adding two more low entries will not change the center of the data set. Slightly if you want, just one spot to the left. But the mean will be highly affected. It will be much smaller if I add, like for example, let's say I have these grades, 90, 100, and a 40. That would be a tragedy, because the mean, the average score will definitely be pulled to the left a lot. But look what happens, so X bar and the mean, and the median will still be 90. Because when I arrange these three scores, 40, 90, and 100, in ascending order, the mean, because the data set has an odd number of entries, the median will still be a good score. But look what happens. Without the 40, I had 95% in the course. And I managed to mess up on one test. Here's what happens, right? I have 190 plus 40, but this time when I divide it by 3, look where it's going. 77%. So it dropped almost 20 points. Right? I mean, from 90 to more than 20 points. So the mean is highly affected by even one low score, but not the median. The median is still here. I can still say that most of my grades are good, because they are. Same thing with skew to the right. So this will be the median, still where the bulk of the scores are. But if I get a 90%, then the mean will be higher than the median. So that's why we call resistant. It's resistant to extreme values. That's what resilient or resistant means. Not affected by extreme in the sense of not in the bulk, out extreme values or entries. So that's the meaning of resistant. So that's why we prefer, when the data is skewed, we still want to see where the central is, but we don't really want to look at that as a measure. We want to look at this as a measure. That's all it means. So page 2 is finished. We can move on. Mean and median for different distributions. We already said that. I just have one thing to mention before I talk about the mode. Okay. When the distribution is symmetric, not skewed, for symmetric distribution, both are good. The mean and the median. And they should be the same if it's very symmetric, perfect, bell-shaped, etc., etc. They should be in the same spot or pretty close. So that's for the symmetric distribution. The third measure of central tendency after the mean and the median is the mode. So this is number 3, mode. The most frequent, so I'm going to